Hi, everybody. Got a few people joining. We'll give it a few minutes here. Hello, Wendy. Give me a thumbs up if you can hear me, just so I make sure my audio is working. Hey, Kim. Awesome. All right, welcome to our fourth Need Live. I'll give a few more minutes here for folks to join. I see a lot of familiar faces again. Just wanted to take a second to welcome you all, give some people an opportunity to check their notifications and hop on in here. Today's lesson is going to be hydropower themed. We changed things up a little bit. So we're going to be focusing on hydropower. Kim Swan from Need is going to be moderating, and she is going to answer some questions today. She'll be looking for comments and things. She's already started answering some of the questions. For folks who have to hop out early, as Kim had mentioned here, we will be saving these to our YouTube page and uploading the link to these lessons after the fact, so that you all can come back and check out what you missed, or if your connection is funky today. I know it's storming pretty heavily on the East Coast, so if you have weird signal, or if my signal goes funky, we'll hopefully get it saved for you all so that you can pick up at a later date or share with students, or maybe share with other family members who are looking for something fun to do. So welcome, everybody. Like I said, today's lesson is going to be hydropower focused. Hydropower deals with moving water energy. And so I'm going to show you some supplies quickly here that you might need. I will do an overview of these again as we get closer to the activity. But bear with me here. I'm going to switch the direction on the camera. So just in case you need them for now, the things that we're going to use today, I have some scissors here. I have 2 cups. These are just plastic cups. You can use foam cups. If you don't have disposable cups, you can use a glass, but you might need some extra, something extra to kind of hold our contraption in place. So we're gonna cut one of these, make some marks into it and cut it apart here briefly. The other one just has water in it for now. We're doing a hydropower activity. Makes sense, we're gonna need some water. And then I have some tape. I also have a hot glue gun. If you've got access to that, great. If not, tape will be fine. We'll make do. I have some thread, a whole lot of paper clips, and I have a foam craft ball for today. If you don't have a foam craft ball, you can make sort of some accommodations. Clay was mentioned on the supply list. Clay will work. You could try and do, make a ball out of packing tape or duct tape, and that might be a suitable solution. There's lots of options for engineering your own version of this, but this little craft foam piece works pretty well. If you have some planters at home that have like foam in the planters for fake flowers or real flowers, you could cut some of that up to use as well. I have a dowel rod here. I didn't actually have a round pencil, but you're gonna need a round pencil today, or something round like maybe a chopstick, or perhaps a skewer or something along those lines. And we're gonna sharpen it. So I have my pencil sharpener. I have a funnel just to make things neater on my kitchen table here. And then I have a ruler. And last but not least, I have some wooden spoons. And I'm going to use wooden spoons, but you could very easily use plastic spoons as well. You need a spoon that you can manipulate or break apart in some way. So you're going to have to use some hand power to make this activity today. So those are, again, are a screenshot of our materials, just in case I want to get one more look. I'm going to plug in my my hot glue gun here so that I'm ready to do some construction. One thing to be sure of is if you're gonna use a hot glue gun, make sure that you have something underneath it. I always have glue left over on the table or counter, and somebody isn't proud of me when I do that. So, like I said, we're gonna be focusing on hydropower today. You're gonna need some basic materials. If you don't have them, feel free to kind of watch along and look for ways you can modify from things in your kitchen or your junk drawer or whatever. So hi to all of my friends out there. Hi to all of our need people. If you have questions today, make sure you ask them. Kimberly in the chat is gonna be moderating and looking for questions that you might have. As a reminder, we're gonna go ahead and save this video to our YouTube account, and we will share those links both on Instagram and on Facebook after the fact, hopefully a little bit after the session. So if you haven't gotten your materials out, go ahead and get them. This activity is actually one of my favorites, and we're gonna be focusing on hydropower today. So hydropower is energy of moving water. And energy, for anybody who's not familiar with that term or hasn't gotten a definition of it or is feeling low amounts of energy. Energy is our ability to do work or make a change. And around us, all over, we use energy in lots of different ways. You use energy to make light, to make heat, to fuel your digestive system, and to be able to hold your phone like this so that you can watch this live stream. And we use lots of different sources for that energy. In our body, we use chemical energy from the food that we eat, but around us, we might use petroleum as gasoline in our vehicles or diesel fuel. We might use biomass, like we talked about on Tuesday. If you were joining us on Tuesday, we might use biomass to burn for a fire or to generate electricity. We might use solar energy to generate electricity or to heat some water if we're camping, or if you're lucky enough to have a solar water heater. And you might use natural gas to cook with or to heat your home if you're having a cold snap this weekend, like some of us might be. So hydropower is energy that we can use coming from the movement of water. And we've been using moving water to do work for centuries. Little mini history lesson for you. The Greeks used to use water to grind grain in ancient Greece. In Mesopotamia, way back when, long time ago, they built dams to help irrigate their crops, to help provide enough pressure to move things downstream, and to get all of their equipment to, and all of the cool things that they were building in the Egyptian times to where they needed to be. We've been using water to move boats. If you've ever seen a riverboat with a big wheel on the back, nice little time for a Tina Turner song, if you know that jam. We've been using water to move things downstream, but also to pump and grind and make machines go. So what we're gonna do today is pretty much power and do some lifting with the movement of water. And so we're gonna make a water wheel, and water wheels are just like turbines, and turbines are things that use the moving energy and then transfer that energy to something else. And so our water wheel is going to do some lifting today. We're gonna lift some paper clips. It's very easy to do this. This activity is easy for lots of different grades and ages, and it can be a fun little family competition if you have enough materials that everybody can build their own. So you can sort of line them up and see who is able to do best. Okay, so take a break from chatting for a second and let's start building. So the first thing you're gonna do is whatever your device is that you're gonna use for the foam craft ball, whether it's a piece of clay or a ball of tape or something, you basically need to make a hub, a thing that's gonna hold our pencil. And the pencil, or in my case, the dowel rod, is gonna serve as our axle in our turbine, our turning piece. It's gonna stay in place, but allow it to roll, sort of like the axle on a wheel has the tire around it, and the axle stays in place and converts the motion to the movement of the round item, okay? So So this guy is what's gonna hold our blades. You can use clay, like I said, but I'm gonna use this foam craft ball because I have one of these. And what we're gonna do is we're also gonna have to sharpen our pencil. And so I've got my little pencil sharpener here, and this works for a dowel rod. So if you've got a dowel rod lying around for whatever reason in your craft bin, I'm gonna sharpen this mostly so that I can stick it into the craft ball. If you don't have a pencil sharpener, you can always find a nail or something else kind of sharp to kind of wiggle it in there and get it started. But I'm gonna push this puppy through like this. I gotta use a little force, but be careful on the other side. So I'm gonna poke it down through the table so that I don't poke it through my hand. Don't necessarily wanna have to go to seek medical attention today if we can help it. And I'm gonna scoot this the whole way through towards the middle of this dowel rod. So you can see I'm rolling it around, but this is staying pretty snug in place. If you're using clay or some other substitute, just make sure that this will stay put while it rolls. So you don't want this to slide up and down or side to side when your dowel rod or your pencil is rolling. Make sense to everybody? Anybody have any questions so far in the comments? All right, we're gonna keep rolling. I'm gonna look out for questions. If you have this on here and you find that it's a little too loose, you can always take your glue or a piece of tape even and put a little glue like I'm doing here around the sides, and that will just hold it in place. And so if you have Elmer's glue or if you have a little tape, just even take a piece of tape and stick it around, wind it around your dowel rod to kind of just keep this guy snug in place. Even Scotch tape will be enough to kind of keep it and resist it from sliding either way. Okay, so that's step one. Pretty easy, right? Step two is we're gonna take our blades. And now this is when if you have plastic spoons and you're not feeling very strong today, you might need some help for this, but you can snap them. I have my wooden spoons. These are the ones that people eat, like Italian ice, and those little ice cream cups, my favorite, are like the Breyers ones. So I really like ice cream, so I have these. We're gonna use these wooden spoons, and the wooden spoons are gonna get inserted into here like the blades on a water wheel on a riverboat, or the blades on a turbine of any kind, sort of like you might have seen with a wind turbine. The only problem is we need to make sure that these blades are going to fit inside the opening of our cup where we're gonna pour the water down. When we're gonna pour water on top of it, we want a place to contain the water since we're inside right now. So in order to make sure that we do that, I'm gonna have to snap these off. You can snap them, you can cut them. I think it's just as easy to snap them, but I'm gonna kind of do this. And if you have a raw edge, that's okay, because it's going to just poke right into your clay or your foam ball or whatever you have. Now you might need to finagle it a little bit if you're using a substitute like some tape or something like that. So we're gonna need to put them in there and squeeze them in there. The good thing about clay or a foam ball is that you can kind of squeeze it in there as much as possible and put some pressure down on it. If you need to cut, you can cut. My scissors will cut this wooden spoon. If you have plastic spoons, you might need to use some leverage there, but I'm gonna push these guys right in there like this, okay? And if you need to, when you push them in, if you find that they're a little too loose, I'm just gonna run a bead of glue with my hot glue gun. You could do, again, with some tape. You could do with Elmer's glue. If you use Elmer's glue, it's gonna take a minute for it to dry, or a couple minutes. So just be mindful of that. If you're lucky enough to have a hot glue gun, those low temp ones are really good. The glue will dry really, really quickly. And so it will keep these puppies in place, okay? So bear with me here. I got my 2 done, and I'm gonna do 2 more. I wanna try and make 4 blades if I can. And one of the important things that you should know is I've made sure that they're pushed in enough so that when I spin this, it will spin freely and not hit the sides of the cup. Because if it hits the sides of the cup like you see here, we're not gonna move or generate any energy here. Okay, we're not gonna be able to lift anything. So repeat the process with 2 more of these spoons. Slide them in here. Let me see if I can do this without glue on this one. This one's good to go. Okay. This one I might need to trim a little bit. And this could be a trial and error process because once you get them in there, you might find that one's a little too long and one's a little too short. So you might need to re-engineer and redesign, and that is okay. That's all part of the scientific process. So I think this one's gonna be a little too loose. I'm gonna put a little bead of glue down on there so that I can get that cranking. I am also gonna turn my glue gun off because I think I'm done with it for now. So just to keep from wasting glue and wasting energy, I'm gonna turn that off so that I'm finished. And again, I just wanna check and make sure that when I spin it, it's gonna stay in place, okay? Now, another thing that I'm going to do to make sure when I spin it, it stays in place is I'm gonna alter my cup a little bit. If you are using nice glasses from your kitchen or a nicer plastic cup that isn't disposable, you might need to stick like some clothespins on either side, and I can demonstrate that here in a second. What I'm gonna do is I'm gonna take the side of my cup and I'm gonna cut a small little V in the side of my cup, like you see there. And I'm gonna do that on 2 sides of the cup, so one's directly across from the other, or I'm gonna try to do it. If you want to, you can use a ruler and make sure it's perfectly even. And again, you might need to use a little force here to make sure it works, to get over that lip on that little solo cup there. Okay, so when I scoot this in, the important thing to check again is that when I put this in the notches, the dowel can spin and the blades can turn without hitting the side. And what I've got, unfortunately, is a situation where my blades are a little close to hitting the side. So I'm gonna have to take this guy and try and scoot him in a little more. Now we're in business, okay? You should be able to spin it really freely like that, okay? So we are literally almost done, almost finished with this activity. The last little piece we're gonna do is now we've got our water wheel. Water is going to move, hopefully, these blades for us. And remember, we said hydropower is the ability to do work or make change. So we're gonna use the energy from the water transforming into motion to do some work. And the work today that we're gonna do is lift some paper clips. In order to lift something, we're gonna need something on the end to attach here so we can lift it. So we're gonna take some string, and it says the instructions for this activity. We'll link the instructions afterwards too. So if you want a paper reference to go off of, we'll make sure that you can get to the guide that has these instructions. The paper says at least 30 centimeters. That's about the length of a ruler. So I'm gonna eyeball it. Probably won't be exact because I got one set of hands here. So I'm gonna give myself a little extra tail just so that I have enough space to tie it onto the end of our dowel rod. And I would recommend that you do this on the end of the dowel or your pencil that's not already sharpened so that you don't have any extra reason for that string to fly off at any point. It's more likely going to come off the pencil over time if it's on the pointy end because that end is a little smaller than the rest, okay? So what we're gonna do with this thread is we're going to tie one end of it to a paper clip. And this is where I think this is the hardest thing we're gonna do this whole activity is tying the thread. Because if you're like me and your fingers don't like to work with thread, it sometimes is a little harder than it may seem. So we're gonna need to make a little knot. So I've done my first little loop there, and we're gonna try and do our second knot here. Yep, struggling already. If you're following along, I hope you're faster than me. Here we go. Got our knot on there. And this is actually gonna serve as like the first paper clip, but it's beautiful because it's also gonna act like a hook so that you can hook other paper clips onto it and add mass to your design to see how much weight your water wheel can actually lift or how much grain it could grind. So you guessed it, what are we gonna do with this other end? We're gonna tie it onto the end of the dowel rod. And this is again a situation where tying hopefully goes a little easier for me this time. I'm tying it onto our end here. And I'm also going to take a little piece of tape just in case to keep that string in place, okay? And what you want to do is you want to test it before you do any work with water. And you want to make sure if you spin it, it's going to wind on itself. So when I spin it, maybe I should cut my tape down a smidge, bigger piece of tape than I planned on, just to keep that knot in place because I'm using some heavier duty thread. This is like upholstery thread. So I want to make sure that it's going to stay in place. And that upholstery thread is harder to get tied in a knot. So what we're going to do is we're just going to check that when I spin it, it winds up on itself. And you see how it's kind of winding? All right, perfect. Now, the other thing to note, I don't know if you saw that, but when you're working with these cups and with your water wheel is you will probably have a tendency when you're holding this cup to squeeze on the sides. If you squeeze on the sides of the cup, what's gonna happen is you're gonna change the circumference of the cup on the top, and what that's gonna do is push in on your sides and make it harder, more likely, for your wheel to keep spinning freely. So you wanna try and avoid at all costs squeezing in on this because it's gonna jostle your water wheel and maybe affect your results and the ability of your design to do its task. So another key component here as I'm scooting this over is we're gonna need to be able to hang this guy off the table. So what you can see is I'm hanging this string off the table. And when we pour the water down on top of it, we're going to want to be sure that it lifts the whole way up. So see how it's spinning there? Now, I am doing the work and spinning it with my hand. Now it's time to see if water can do work. And you might notice that it's not flowing smoothly again for me. That's probably because my blades aren't evenly sized. So one of the things I could do to redesign this when I'm done is take this longer piece and make him a little bit shorter, okay? But for the interest of time, we're just gonna pour a little water over the top. And this is one of the things where it's nice to have an extra set of hands. I don't have an assistant today, so we're gonna do our best. But you're gonna try and just simply pour the water on the blades and see how it spins there. Whoops, if I get it on the blades. My blade is stuck on the side. Okay, I obviously have to fix that. So you're now seeing part of the engineering design process. So bear with me, I'm going to fix my little wheel here. And it's probably good that we did that together so that you all can see a common mistake. If you find that your wheel isn't working or if the slot that you made is too loose, the good news about clay and foam is that you can usually just redistribute the piece of your wheel to another slot and make another slot. Now, as you go, you may want to make sure that you haven't made them unevenly spaced. You can also see if you'd like to add more blades, and what we'll see automatically is that is spinning so much better. Okay, so much better. All right, so last little piece here. I'm gonna go ahead and try one more time to pour on the top, and hopefully you can see it's spinning. And then I'll show you that it's wound my pencil up towards the top. The goal is to try and get this puppy lifted the whole way. I ran out of water, so what I would do in the interest of saving water, is we're going to go ahead and pour the water. I have a funnel here. I'm gonna pour the water out of this experimental cup back into my regular cup. I'm using a funnel because I'm messy. You can probably get around it without the funnel. But we're gonna try this one more time and see if we can get our water wheel to lift more weight. And it's winding. And a strategy is you wanna pour it on the wheels or on the axles and not on the ball itself. You can see that with half of the water in this cup, I wound this the whole way up. Now, what I would want to do going forward is experiment with adding more mass. And so what I would do is I would move this back a little bit so that y'all can see. Sorry about the technical difficulties with my fancy phone stand. What I would do is I would add some extra paper clips, and you can just take the paper clips and clip them on. What I did was just like that. You could also tie more to the end of the string. I think that's more work. If you want to, you can just keep opening the paper clips and clipping them together using the openings. And so I'm gonna scoot it on just like this. I don't know if you can see that close up there. Maybe pull it up closer to you here using a colored paper clip, and I'm just clipping it on. So now I have 3 paper clips. I would wanna see how many paper clips I could clip in a long period of time. Another option, if you don't wanna pour from a cup or if you're working one-handed like I am, you could absolutely use your faucet from your sink because you could more closely direct the water right onto your wheels or to the blades on your turbine. But what I would 100% suggest, again, in the spirit of conservation, is sticking a pot or a tub underneath it to collect some of that water and then recycle the water afterwards, using it to water your plants outside or maybe put in a bowl for your pets if you haven't run it through other dirty things in your sink or on your own dirty hands. But just an option to save some of that water. If there's a way that you can use it for something else, 100% recommend that. So that is our water wheel. And the competition aspect here comes in as you build your own. See how you can redesign, enhance your model, and see whose is gonna lift the most paper clips, and just keep adding those paper clips until you can't get it to lift any longer. The other thing that you can do is if you wanna add to the challenge and see who can do the most in the shortest amount of time, because power is work over time and we're using hydro to power our lives, you could see how quickly it lifts those paper clips. So if you and your brother or sister or your mom or your dad or your grandmother are gonna work on this activity, you could all put the same amount of paper clips on and see who lifts the paper clips the same amount in the shortest amount of time. And then you'd be doing a power calculation, which is really fancy, higher level science. So that's our water wheel. And again, a water wheel is really just what we're using at a hydropower dam or on the back of a riverboat. It's basically a turbine that uses motion of water to do work. In this case, we're lifting weights. You could, again, like I said, use it to move a boat, to grind grain, or to, in the case of a hydropower dam where we generate electricity, instead of lifting weights here, what we'd be doing is we'd be attaching a generator to the end of this. And that generator would turn as this wheel turns with water. And we'd be using the water to turn the generator. What's inside a generator? A generator is magnets and coils of wire. And when you move a magnet near a coil of wire, you can generate electricity. And those electrons get sent right out to the customers and the people who need it. So that is our water wheel. That is our water wheel model. You can find this activity in Need's Wonders of Water curriculum, and it is a lot of fun for everyone, and I really hope you enjoyed it. I hope you'll come back and join us again for a future activity. Does anyone have any questions before we cut it for the day? Awesome. Thank you so much for joining us. Again, you can find this activity afterwards on our Instagram and our Facebook pages via a YouTube link. You can download the activity from that we'll have it in the text there. We're not fancy enough to do the swipe ups, but hit that like button if you enjoyed your time today, and we will see you next Tuesday for our next live lesson. So everybody have an awesome weekend ahead. Have a happy Good Friday if you are not working tomorrow or not doing schoolwork tomorrow. And make sure to share these activities with your friends and include your family in your energy fun. Thanks, everybody.